Hi everyone. So in this video we are going to cover peak detector circuit. So previously we have seen clamper circuit. Now we are going to see peak detector circuit. So what is a peak detector circuit? As the name suggests, it will detect the peak value. It can detect the positive peak as well. It can detect the negative peak as well. So it will detect the peak value. So there will be two peak detector. Positive peak detector, that means that will detect the positive peak value. Positive peak detector means detect the positive peak value, and negative peak detector will detect the negative peak value. And if you try thinking of this circuit, what will happen? Let's assume you need to detect a positive value. So that means positive or negative value, that means you need a capacitor, a storing element, also a switch. Because if it turns on, it will detect the value, and if it is turned off, then only the peak value is at the output. So you need a switch and a capacitor. So this is the circuit of positive peak detector. So let's analyze the circuit. The given input is this one, sinusoid input. The given input is sinusoid input. So this time is T by 4, this time is T by 2, this time is 3T by 4, and this time is T. So what do you think what should happen? Input is increasing. For T equals to 0 plus, V in is positive, V in is greater than 0, right? And if it is greater than 0, this is greater than 0, this side is greater than 0, and this is 0. That means diode will be on. Diode will be on. And diode will be on. Let's call this as VC. VC is equals to V out only this time. VC is equals to V out only. So what will happen? The capacitor will start following the input. Capacitor will start following the input, and it will go till 0 to T by 4. It will go till T by 4. The capacitor will start following the input. It will go till T by 4. Why T by 4? Because after that the nature is changing. After that the input is decreasing. So that's why I am telling till T by 4 only. So V0 and VC waveform, both waveform we are plotting. So VC will be equals to V in till 0 to T by 4. So till 0 to T by 4. 0 to T by 4, it is equals to V in. So it has reached till this value. This value is Vm, or we can say 5 volt, plus 5 volt. Now at the next moment, what is happening? Now this capacitor is charged to 5 volt. This capacitor is charged to 5 volt. At the next moment, at t equals to t by 4 plus, at t equals to t by 4 plus, what is happening? Input value is 4.9. Let we can let input value to be 4.9. At t by 4 plus, the value is lesser than 5 volt. So it can be 4.9 volt. Let's assume it is 4.9 volt. So here you are having 4.9, and here you are having 5. This end is at 5 volt, and this end is at 4.9 volt. What will happen? Diode will be turned off. Here you are having 5, here you are having 4.9. What will happen? The diode will be turned off. And VC is at 5 volt only, right? What will happen? Diode screen has got black here. This one. Diode will be off. Now your diode is off. Now to turn on the diode, what you need to do? To turn on the diode, this end is at 5 volt, this end is at 5 volt, and this end is at VE. Now from here to here we are going. To turn on the diode, VIN should be greater than 5 volt. VIN should be greater than 5 volt, because VC is at 5 volt and this is your VIN. VIN should be greater than 5 volt. Then only the diode will be turned on. Here also there is one thing, that is RC value is very high. RC value is very high. This should be written there. I forgot to write it. Why RC value should be very high, that we will tell. VIN should be greater than 5 volt, then only diode will be turned on, which is not possible, because input is maximum value is 5 volt only, because this is our input, maximum value is 5 volt only. So this is not possible. So diode will always be off. Diode will always be off. Diode will always be off. That means VC value will be stable at 5 volt. Vc value will always be at 5 volt. Now people may have one doubt, like they will say that, sir, the diode is off now. The diode is off. So what will happen? If the diode is off, how will the circuit look like? This is how the circuit will look like. If the diode is off, this is how the circuit will look like. The capacitor is charged to 5 volt. The input is gone. The input side is gone. Diode is off. So they will say that, sir, the capacitor can discharge. But I have given that RC value is very large. Since RC value is very large, the capacitor will not discharge. It will just remain at 5 volt only, because RC value is very, very large. Are you getting this point? So we can write this point in the next page. So at T by 4 plus, one thing we get to know that diode is off. Diode is off. So this is off. And then we are having our capacitor and a resistor. This capacitor is charged to 5 volt. There is this input which is not in the connection now. The connection is broken, and this is our output. Now the capacitor will not discharge. Why so? Because RC value is very large. So Vc steady state will be 5 volt only. So Vc will remain stable at 5 volt. It will remain stable at 5 volt like this. This value is 5 volt. Are you getting this point? So our target was to detect its positive peak value, and that is detected. That is 5 volt only. Did you understand this point? Well and good. Let's move on to the next circuit, that is negative peak detector. The same input is given. You can analyze the circuit on your own. The same input is given. Tell me one thing. For 0 to T by 2, for 0 to T by 2, Vin is positive. Vin is positive. For 0 to T by 2, for this complete cycle, Vin is positive. What will happen? The diode will not even get turned on. The diode is off. Diode is off. Diode is off. For the complete cycle, diode is off. And there is no initial charge on capacitor. So capacitor will be 0 volt only. Vc will be 0 volt only. Right? For 0 to T by 2. And this box should not be there. Vc will be 0 volt only for 0 to T by 2. It will be 0 volt only. Yes, so for 0 to T by 2, Vc will remain at 0 volt only. Like this. This is time T by 2. This will be 3T by 4. This is 2T. This is time T by 2. Now what we will see? Now we will see for at T by 2 plus. At T by 2 plus, what is happening? V input is less than 0. This value is negative. Let's assume this value is 0.1. Here you are having minus 0.1. Here you are having 0.0 volt. What will happen? The diode will turn on. At positive side you are having 0 voltage. At negative side you are having negative voltage. So diode will turn on. That means your diode will turn on. Now the diode has turned on. So what will happen? Vc or V0, you can say, whatever it is, because Vc and V0 both are equal only. Vc now will start following input. Till what time it will follow the input? Till what time? Until the nature doesn't change. It is decreasing only, but after 3 by 4 it is increasing. So until the nature is changing, it will follow the input. That means from T by 2 to 3T by 4. Till this time it will follow the input only. So till this time it will follow the input. It will be minus Vm only till this time. This is 3t by 4. Now after that, at 3t by 4 plus, at t equals to 3t by 4 plus, at t equals to 3t by 4 plus, what will happen? At t equals to 3t by 4 plus. So what is happening? My VC is following the input. That means this is charged to minus 5 volt now. VC capacitor is charged to minus 5 volt. This is minus Vm. That means minus 5 volt. Or in bracket you can write minus 5 volt. This is charged till minus 5 volt. My Vin is negative. That means my capacitor is getting charged in this direction. In the opposite direction. If it was positive, it was getting charged in this direction. But if it is negative now, so it is getting charged in this direction. So it is charged to 5 volt like this. So if this potential is 0, this potential is minus 5. The next moment, what will happen? At 3t by 4 plus, at 3t by 4 plus, this potential will be some minus 4.9, some minus 4.9. So you can say that Vin will be minus 4.9 volt. We can assume it. Some minus 4.9 and Vc is at minus 5 only. Vc is at minus 5 only. This potential is at minus 5 and this potential is at minus 4.9. Tell me what will happen? At P side you are having minus 5, at N side you are having minus 4.9. N side you are having more potential. Minus 4.9 is more than minus 5. So at N side you are having more potential, that means diode will be turned off. Right? So diode will be turned off now. Diode will be turned off. That means diode is off. And now if the diode is off, to turn on the diode, what should happen? To turn on the diode, what should happen? What is this potential? This potential is Vin. What is this potential? This potential is minus 5. So your Vin should be less than minus 5. Your Vin should be, the potential of N should be lesser than the potential of P. Potential of N is Vin. Potential of P is minus 5. So potential of N should be lesser than potential of P. So Vin should be lesser than minus 5, which is not possible. The diode Vin should be less than minus 5, which is not possible. That means diode will always be off. Will always be off. So if diode is always off, that means Vc value will be at minus 5 volt. This will be steady state. Why this will be steady state? Because the capacitor cannot discharge further. Since RC is very large, we will also see if RC is not that much large, what will happen. We will also see that condition. But for now, we are assuming RC is very large. Since RC is very large, the capacitor cannot discharge further. Well and good. So what is happening? Now our output will remain at minus Vm only. So we needed a circuit to detect the negative peak voltage and we got it. We needed a circuit to detect the negative peak voltage and this circuit is detecting the negative peak voltage. This is minus 5 volt. Well and good. So let's make 4 circuit and see one by one which circuit is what. So circuit A. This is capacitor C. This voltage is Vin. So Vin is constant for all. That is Vm sin omega t. So you need to tell me the output. Given that Vin is same for all, that is Vm sin omega t. So tell me the output. What will be the output of this circuit? Then exactly the same circuit. I will just copy it here. but the polarity, diode polarity will be changed. This output you need to tell me. Then this is your V in. This output you need to tell me. And then this is the circuit, and this output you need to tell me. Okay, so 4 circuits are given. Also you need to tell me which one is what circuit, which circuit is called what. So which circuit is that? That is positive clamper circuit. It will shift the waveform upward. You see the arrow, diode arrow, it will shift the waveform upward. So this is what? This is positive clamper, right? And what will be the output? Output will be Vi plus Vm. It will shift the waveform upward. What is this? Arrow is downward. That means that is negative clamper. This is negative clamper. And what will happen? It will shift the waveform downward. So V in minus Vm. Or how you can say, your target is to turn on the diode. The diode will be turned on at plus Vm. So capacitor will be charged at plus Vm. So V in minus Vm will be your output. Here your target is to turn on the diode. Diode will be turned on at minus Vm. So your capacitor will be charged till minus Vm, like this. So V in plus Vm will be your output. This is how also you can tell. You don't need to mug up the output. You can simply derive it within 5 seconds. Here, what is this circuit? This circuit is positive peak detector. The arrow is going this side. That means that is taking the input waveform at the output. So this will detect positive. This will detect positive peak. Also, you can see that when will the diode turn on? When will the diode turn on? When the input is plus Vm. At the maximum voltage, when will the diode turn on? When input is plus Vm. So it will turn on at plus Vm. If the diode is on, what will happen? The same voltage will be going towards the capacitor. So output will be plus Vm only. So this is how also you can remember. This is peak detector. So in these kind of circuit, whenever you see these kind of circuit, and if they are asking steady state output, so your target should be to turn on the diode. That's it. If they are asking steady state output, your target would be how to turn on the diode. That's it. So to turn on the diode, you have to apply plus Vm, maximum input voltage. So if you are applying plus Vm, so at that time, what will be our output? Output will be plus Vm. And how will you? This is positive peak detector. And what about this? How will you turn on this diode? When you apply minus Vm, so your output would be minus Vm only. So here, because here this is N side, so you have to apply minus Vm. So if you are applying minus Vm, your output will be minus Vm only, right? This is negative peak detector. So this is an important slide. These are the very standard circuit. So this should be in your mind that, okay, just by seeing the circuit, you should be able to tell what should be the output. Okay, this is positive clamper, this is negative clamper, this is positive peak detector, this is negative peak detector. That's it. Now let's move on to a good question. This is the question given. The input waveform is not visible to you. Now it is visible. This is your input waveform, right? Now you have to tell me the steady state output voltage. Also you need to draw the output waveform. What will happen? What is one thing I told you? You have to turn on the diode for the steady state output. You have to turn on the diode. Yeah. So what I was saying, what did I tell you? What should be our target? Our target should be to turn on the diode. That's it. At what voltage the diode will turn on? At any positive voltage it will turn on. But we have to apply the maximum positive voltage. What is the maximum positive voltage in the input? That is 10. So if you apply 10 volt, the diode will be turned on. So simply your output will be 10. So your steady state output is 10 volt. That's it. Are you getting this point? Or how you can see? When the input is positive, what will happen? The diode will turn on. See, just as the diode turns on, capacitor will follow the input. When the diode turns on, जैसे ही डायोड टर्न ऑन होता है, कैपेसिटर क्या करेगा, इनपुट को फॉलो करेगा. V naught will simply be equals to V in. It will start following the input. So it will follow the input like this. Now at the next moment, now what is happening? Our capacitor is charged to 3 volt. At the next moment, our input is 2.9. Here, our input is 2.9. 3, 2.9, diode is off. 3 here, 2.9 here. 3 this side, 2.9 here, diode is off. Understood? And now diode is off. That means it will just remain at 3 volt only. Till what time? Until your input is higher than 3 volt. Here we are having 3 volt, that is constant. Now suddenly my input rises up to 3.1 volt. At the next moment it is 3.1 volt. What will happen? The diode will again turn on. Diode turns on. Now diode again turns on. Now again it will follow the input. Again the capacitor will follow the input. Again your output is following the input. So again your output is following the input. It is following the input, following the input, following the input till 5 volt. Till this point we have reached, that is 5 volt. Next moment what is happening? The next moment input is going down. 4.9. Input is going down. Here 5 volt, here 4.9 volt. That means diode is off. Now if the diode is off, what will happen? The capacitor will retain its voltage. So capacitor will retain its voltage. It is retaining its voltage till what point? Till 5 volt. Retaining its voltage, retaining till 5 volt here. Now at the next moment what is happening? Here 5.1 volt. Greater than 5 here. 5.1 volt, what will happen? Diode again turns on. If the diode again turns on, the capacitor will again follow the input. Diode turns on, the capacitor will again follow the input. So it is again following the input. It goes here till what? Till this 8 volt. So till this 8 volt, this is charged to 8 volt now. At the next moment, what is happening? 7.9 volt here. 7.9 volt here, diode again off. If diode is off, what will happen? The capacitor will retain its output. Capacitor will retain its voltage. So till what voltage it will retain? It will not discharge till 8 volt. It will retain its voltage till 8 volt. Now on the next moment, what will happen? This is 8 volt. On the next moment, this is 8.1 volt. So here 8.1 at this point. This is 8.1. So here 8.1 and here 8. 8.1 and 8. That means diode will again turn on and again follow the input. So diode again turns on and again follow the input. And finally, when the input is 10 volt here, after that it will remain at 10 volt only. When input is 10 volt, that means it is charged to 10 volt now. It is charged to 10 volt. At the next moment, what will be my input? My input will be 9.9. That means diode will be off now. If the diode is off, the capacitor will retain its voltage to 10 volt until your input is higher than 10 volt. When the input goes higher than 10 volt, again it will start charging. Then again it will reach till maximum. Then again it will be off. So finally it will detect the maximum peak voltage. That's it. Are you getting this point? And if it was a negative peak detector, then also you could have told the output, right? Do I need to make a circuit for negative peak detector as well? Okay, let's make the circuit for negative peak detector as well. But for now, I haven't made the circuit. So here I will draw for negative peak detector as well. So I guess this I can copy. Let me pause the video and make the circuit. Yeah, so this is the circuit. You need to tell me the steady state voltage of output. Okay, I did not give the values. Let's give the value. This voltage is minus 10. This voltage I am saying minus 1. Forget about other voltage because we already know the final answer, right? This voltage is minus 1. This voltage is minus 10. So how will the waveform go? What will happen? First, negative voltage is there. If negative voltage is there, that means diode will be turned on and it will follow the input. It will follow the input. Until minus 1 volt, it will charge. And when we are having minus 1 volt here we are having minus 1 volt. That means this potential will be minus 1 volt. At the next moment, here the input will be minus 0.9 volt. So N side is having more potential, P side is having lesser potential. That means diode will be off. And if diode is off, the capacitor will retain its voltage. Till what point? Until your input goes higher than until your input goes lower than minus 1 volt. So at this point, here at this point, your input is going lesser than minus 1 volt. Let's assume at the next moment it is minus 1.1 volt. So again diode will turn on. So again it will follow the input. So So again it start following the input, it start following the input, it start following the input, it is following the input only, right? It is following the input only. So it follows till 10 volt. It follows till minus 10 volt. Follows till 10 volt. So this potential is minus 10 volt. Now to turn on the diode, what do you need? You need an input value lesser than minus 10 volt. But is there any input value lesser than minus 10 volt? Here you need at least minus 10.1 volt. Then only diode will be turned on. But is there any value lesser than that? No. So it will just detect the negative peak. It will just detect the negative peak. So your output will be at minus 10 only. Just detecting the negative peak voltage. So your V0 steady state will be minus 10 volt. That's it. Well and good. So we have seen what is the meaning of positive peak detector, negative peak detector. Positive peak detector will detect the positive peak value and negative peak detector will detect the negative peak value. Here one shortcut I told you that you need to turn on the diode at the maximum possible voltage or minimum possible voltage. So here diode will be turned on at plus 10. So output voltage will be plus 10, steady state voltage. And here the diode will be turned on at minus 10. So output will be, steady state voltage will be minus 10 volt. Well and good. Very easy. Let's move on to the next concept. But before that, I want to test your knowledge. So your question is, you need to find the average value of this input waveform. So try finding the average value of this input waveform. This is the input waveform given to you. This is the waveform given to you. You have to find the average value of this. Impulses are there. So what will be the average value? What is the concept of average? Concept of average is area of one time period. Area of one time period divided by time period. Divided by time period. That is the average for a periodic waveform, right? Average for a periodic waveform. Area of one time period, that we write like this: xt into dt, 0 to t divided by t. So area of one time period divided by the time period, right? Now these are impulses. These are impulses. What is the time period of the, what is the time period here? What is the time period of the signal? Time period is t. Now these are the impulses. Now tell me, what is this 5t? 5t is the magnitude of the impulse or the area itself? 5t is the area itself. So in one time period, what is the area? In one time period, what is the area? 5t, right? In one time period, what is the area? That is 5t. So what will be the average? Average will be 5. So answer is, average is 5. That's it. Area divided by the time period. What is the area? That is 5t divided by time period. That's it. In one time period, what is the area? Area is 5t only. From 0 to t, what is the area? 5t only, right? Let's move on to, this was signal A, this is signal B. So tell me the area of this signal now. So here there are two signals. Impulses are there and then there is a square waveform. 5 0 5 0 5 0 5 0 5 0 5 0. So two signals are there. So again we have to find the average. So what we will do? First we will write the area in one time period. In this much of time period, I need to write the area in one time period. In this much of time period, I need to write the area. So two signals are there. First is the impulse. Area of impulse is itself written. So that is 5t by 2. Plus one more area will be there. What will be that area? This area. What is this area? That is also 5t by 2. This impulse is written. The area of that impulse is 5t by 2. What is the area of this square waveform? That is also 5t by 2. Divided by time period. What is the time period? Time period is t. After t time period, everything is being repeated. 5t by 2 plus 5t by 2 divided by t. That means 5t by t, that will be equals to 5. So here your average is also 5. Are you getting this point? Very simple signal system question, but I just thought that I should deal it as a question so that you will not get confused in the later analysis. The analysis I am going to tell you, that is very intuitive and very conceptual, and you will certainly like it a lot. So before that, I am clearing your concept, and I am just letting you know that you know the concept or not. Okay, so I hope you have understood the concept of average. Area divided by the time period. Area over a complete time period divided by the time period. So here 5t by 2 plus 5t by 2 divided by time t. Average will be 5. Now this is also a very conceptual question. You need to tell me the current at time t. The switch is being closed at time t only. Time capital T. The switch is being closed at time capital T, and you need to tell me the current at that particular time. And your capacitor is initially charged to 3 volt. Initial charge is there, that is 3 volt. Now I am turning on the switch. So what will happen? If I turn on the switch, what will happen? Suddenly your capacitor will reach to 5 volt, right? If I turn on the switch, suddenly your capacitor will reach to 5 volt. This is your capacitor if I turn on the switch. So tell me one thing, your VC T minus, when the switch was not closed, when the switch was open, what was your voltage? 3 volt. Your VC T plus is what? 5 volt. What is the equation of ICT? ICT is C dVc by dt. dVct by dt. I am asking at a particular time, that is ICT, at that particular time only. So C into what will be dCVT by dt? Tell me. At that particular time, the voltage changed from 3 to 5. What is your VC waveform? What is your VC waveform? What is your VC waveform? This is your VC waveform. Look, if you haven't studied network analysis perfectly, I would recommend you to study network analysis. But here, whatever that is required for analog electronics, that I am telling along with that. But all these things, these are the very basic thing of transient that I have already told in the network analysis playlist. From there also you can see. So from 3 to 5 at time t, this is 3 volt and this is 5 volt. So it is jumping from 3 to 5, right? It is jumping from 3 to 5. There is a jump of 2 volt. So dCVT by dt, what we will write? The change in VC voltage, that is 5 minus 3 divided by time t. What is time t? That is nearly equals to 0. So the current is infinity, but we will write it in this manner, 2C delta t. Impulsive current will be there. This would be a wrong thing to write actually. I should write ICT only, ICT. ICT would be 2C delta t minus t. Because at time t only we will have an impulse. ICT would be C into what is the change? That is from 3 to 5. 3 to 5, that is the change. That means you are giving 2C charge. What is Q? Q is equals to CV. Initially, what was the charge? Voltage was 3 and capacitance value is C only. So 3C was charge. Now, what is the charge? Charge is 5C because voltage is 5 and the capacitance value is C. So what is current? Current is dQ by dt. So how much change is there? The change is 2C. dQ is 2C and time is nearly 0. That's why 2C delta t. Although these things should be understood in the network analysis itself, but here again I am giving you the concept so that you must not forget it. Or also what you can do, you can simply integrate this waveform. If you have studied signal systems, you just need to integrate this waveform. How do you integrate a waveform? ICT would simply be C dVc by dt. What is ICT? C dVc by dt. So just the waveform, just the differentiation of this waveform into C, that will be our final answer. So what will be the differentiation of this waveform? This is a constant. Differentiation of constant will be 0. Differentiation of constant will be 0. Now at time t, what is happening? At time t, this is not constant. At time t, there is a jump from 3 to 5 volt. So there is a jump of 2 volt. So there will be impulse of 2 delta t. I should write the impulse should be 2 delta t, but it will be multiplied with C. So 2C. The impulse will be 2C. and this is ICT we are drawing, and then again after that it is again constant, so again it will be 0. So only there is an impulse, that is 2C delta t. So whenever the value of capacitor voltage is changing instantaneously, that means there will be a impulsive current. The current will not be 0. People say the current is 0. No. If the voltage is changing instantaneously, that means there is impulsive current. The current is not 0. At the time the current is infinity. But for a very small time, okay, the current is there, then it is gone. 0 current, 0, 0, 0 current, very high current, then again 0. Understood? 0, 0, 0, very high, again 0. So for a very small moment, very high current will flow and again it will be 0. So there will be impulses. That is this impulse that I have told here. Understood my point? From 3 to 5 it is going. If 0 to 5 it was going, let's assume initially there was no voltage, there was 0 voltage, and then I turned on the switch. So there would be an impulse of 5 delta t, 5C delta t actually. The current would be 5C delta t minus t. There will be an impulse of 5C current, right? So these were the basic of the next problem that we are going to solve. So this is the next problem. We have to find the diode current at steady state, average diode current at the steady state. This is the question and the input is applied. The input is given is plus 5 0 plus 5 0 plus 5 0. You have to find the steady state diode average current. Average current of diode at steady state. ID average at steady state. And RC value is 20T, which is very large but still considerable. RC value is 20T. So what will happen? Let's see that. So let's analyze the circuit. For 0 to T by 2, what is the input? Vin is 5 volt. For 0 to T by 2, Vin is 5 volt. So what will happen? Here 5 volt, here 0. Diode will be on. Diode is on. Diode will be on. And input is 5 volt. So let's assume this is our output. So output will immediately be equals to 5 volt. But if I ask you what will be my diode current, this if I ask you, what you will say? My diode current will simply be equals to IC plus IR. This current plus resistor current. So my ID will be equals to IC plus IR. This we are talking for 0 to T by 2 only. 0 to T by 2 only. So tell me, what will be my IC value? You should be able to tell what will be my IC value. I should write ICT actually. IDT, because the function is will be of time, no? Because we are talking about the time only. So IDT will be equals to ICT plus IRT. ICT will be 0. My question is ICT will be 0. No. Initially the capacitor was 0 volt, but suddenly it is going to 5 volt. So there will be a current, impulsive current. What will be that current? 5C delta T. Initially the charge was 0. Now the charge is 5C. So you are giving 5C charge in no time, dq by dt. You are giving 5C charge in no time. That means the current is 5C delta T. So the current is 5C delta T. This is my IC. Plus what is IR? IR is always 5 by R. Since you are giving 5 volt across the resistor, so the current will be 5 by R. So for 0 to T by 2, IDT is not 0. That is 5C delta T plus 5 by R. This is the current. So IDT if I draw for 0 to T by 2. Five C delta T plus 5 by R. So that is here I should not write delta T like this. 5C. That's it. This is what I should write. Then this is time T by 2. And for till T by 2, this current is 5 by R. The magnitude is 5 by R. Now what will happen for T by 2 to T? For T by 2 to T. For T by 2 to t. So at for t by 2 to t, what is your input? Input is 0 volt now. This input is 0 volt and this is charged to 5 volt. So here you are having 0 volt and here you are having 5 volt. What will happen? Diode will turn off. Got the point? Here you are having 5 volt and here you are having 0 volt. Diode will turn off. Diode turns off. Now the diode turns off. So this relation will be broken. Diode turns off. There is no meaning of input. Now the capacitor is charged to, this capacitor is charged to 5 volt. And in the output there is a resistance R. Now what will happen? This 5 volt will try to discharge, right? This 5 volt will try to discharge. So let's assume if this is V0 waveform, so how will your V0 waveform will look like? So if we draw the V0 waveform as well, on the next page we will draw the V0 waveform. So initially it is 5 volt, now it is trying to discharge 5 into e to the power minus t by RC by this. But since we are taking it from t by 2 times, so I should write t minus t by 2 times. Because this thing is starting from t by 2 time. This thing is starting from t by 2 time. So after t by 2 time it will discharge. Basically you have the window of t by 2 time. You have the window of t by 2 time. So you are starting from t minus t by 2 because this is starting from here, this point. It is starting from this point. That's why you have written t minus t by 2 RC. Well and good. Now it is getting discharged like this. Now tell me one thing. What is the expansion of e to the power minus x? If x is very small, look, RC value is very large. What is RC value? RC value is equals to 20t. That is very large. From this much of expression, RC value is very large. So if this is very small, what we can do? E to the power minus x should be written as 1 minus x, right? You know this thing, right? E to the power minus x can be written as 1 minus x. So what I can do here is that 5 into 1 minus t minus t by 2 by RC. So although V0 should discharge exponentially, but still what we are doing, but still it is discharging linearly because RC value is very large and x is very small. So I can approximate it to 1 minus x only. So it should discharge exponentially, but we can approximate it to the linear discharging. Are you getting this point? So let's make the V0 waveform. And one more thing. So in time 0 to t by 2 to t, what will be your ID? 0. Why so? Because diode is off. If diode is off, that means your ID value is 0 ampere. So in this time there is no ID value. ID value is 0 ampere. In this time ID is 0 ampere. Well and good. So let's make the waveform for, first we can make the waveform for ID. This we can copy and directly paste it here. So this will be the waveform for ID. So for 0 to till time t, 0 ampere. And what about VD? So VD or V0, not VD, sorry, it is V0. So V0 suddenly here rises to 5 volt. V0 first it rises to 5 volt. From 0 to it rises to 5 volt. This is time t by 2. This is time t by 2. Then it falls linearly. It falls linearly. It falls linearly. It falls very low actually because although RC is very large, it falls linearly. This time is time t. Tell me what will be this value? What will be this value? We see V0 value at time t. That will be 5 into 1 minus t by 2 RC. Well and good. 5 into 1 minus t by 2 RC. This will be the V0 value at time t. Here I am just putting t equals to t only. I have the window of t by 2 time. So directly I would have thought like this, 5 into e to the power minus t by 2. Okay, so I can approximate it to 5 into 1 minus t by 2. So now I have the time bandwidth of t by 2. Okay, I have the bandwidth of t by 2. It will be tau is 2 RC. So 5 into 1 minus t by 2 RC. That is what I am getting here. So this t minus t by 2 thing you don't need to do if you have that good enough concept, right? But this is how we do it in theory. So that's why I am writing it in this manner. So 5 into 1 minus t by 2 RC. So here this point will be 5 into 1 minus t by 2 RC. This is the time t. Now what will happen? For t to 3t by 2. For t to 3t by 2. What will happen? Input will again be 5 volt. So this is the input which will again be 5 volt. This is the resistance R. Here you are having some voltage, that is this voltage. This voltage 5 into 1 minus t by 2 RC, that is lesser than 5 volt. This voltage is lesser than 5 volt. So here I can write I am having V naught T voltage here. V naught T voltage here. And this is 5 volt. This voltage is somewhat lesser than 5 volt. And this is 5 volt. So this is your V naught. What will happen? Diode again turns on. Diode turns on. And just as the diode turns on, what happens? Just as the diode turns on, what happens? Your V naught value at T plus would be 5 volt. Suddenly your V naught value rises. Suddenly. It was 5 into 1 minus T by RC. At time T minus. At time T minus it was 5 into 1 minus T by RC. But at time T plus it is 5 volt. From 5 into 1 minus T by RC to 5 volt. Suddenly it is rising. Are you getting this point? And it will remain there. So how will your V naught waveform look like? The diode turns on. So let's forget about this value. So again it will rise to 5 volt. Again the value will rise to 5 volt. अरे यार. And it will remain there till time 3t by 2. This was 5 volt. Then it was discharged to this point. This potential is 5 into 1 minus 5 into 1 minus t by 2 RC. Right? 5 into 1 minus t by 2 RC. Okay. And then again it rises up to 5 volt. Now the interesting question is, what will be your diode current? This is the interesting question for me. And first you have to write down in your notebook, what will be the diode current now? Since diode is on, so it will drive some current now. It will drive some current. What will be the diode current? Tell me. One thing is for sure, that this voltage is going to 5 volt only. Just as the diode turns on, this voltage will be 5 volt. So there will be 5 by R current. That is the resistor current. This is the resistor current. But there will be a capacitor current as well. And what will be the value of that capacitor current? What will happen? Here your voltage was, already the voltage across the capacitor was, what is the scene? Already your voltage across the capacitor was 5 into 1 minus t by 2 RC. Now your voltage across the capacitor has been 5 volt. So what will be the current? The change in this voltage from 5 into 1 minus t by RC to 5 volt. So what will be the current? Current will be 5 minus 5t by RC. This much change in the voltage into delta T into capacitor C. So this much change in the voltage into C is the charge. So this will be the current. Are you getting this point? So this current would be 5C by RC into T delta T. So that would be 5T by R delta T. Did you understand this point or not? This is a very typical concept and no one in the gate industry is going to teach you, but I will show you the question which has come in the gate examination from this particular concept, and that question was tougher than this one. That question was actually tougher than this question. There one more concept will be used. So before that we are solving the easier question. So what is happening? At T minus your voltage was 5 into 1 minus T by RC, but suddenly it rises up to 5 volt. 5 into 1 minus T by RC to 5 volt it is rising. So change in voltage is, what is the change in voltage? The change in voltage is 5T by RC into the capacitance C, that will be the change in charge, and change in charge is current only. So the change in charge is 5T by RC, so the current would be change in charge is 5C into T by RC, so the current would be 5T by R into delta T. So that would be the resistor current, 5T by R, but I should not write delta T here. This is all is happening at time T. So I should write delta T minus T. So this is my diode current. Are you getting this point? Initial waveform was this 5C, 5R. Now what is happening? The impulse has shortened. Now the impulse is 5T by R delta T minus T. Here the impulse was 5C. Now the impulse is this much. And but this current waveform 5 by R, that is remaining constant. So now I can draw the waveform of IDT. So instead of drawing, I can directly copy this one. Now what is my impulse? This is my impulse. The magnitude is 5T by R delta T. Delta T minus T, but I should not write it because this represents the area itself. And for next T by 2 time, 3T by 2. Right? Well and good. Yeah, just one error is there. Actually it is 2. Here it should be 2. That's what I was thinking. It should be 2. So 5 by 5T by 2R. It should be 5T by 2R. 5T by 2R. 5T by 2R. 5T by 2R delta T minus T. So it is 5T by 2R delta T minus T, and this magnitude is remaining the same. Now at 3T by 2 plus what will happen? At 3T by 2 plus what will happen? At 3T by 2 plus, it is charged to 5 volt and this is 0. What will happen? Diode will be turned off again. Diode will be turned off, and the same thing that happened from T by 2 to T, the same thing will happen from 3T by 2 to 2T. Exactly the same waveform. Everything will be the same. Here 5 volt, here 0 volt. The same thing will happen from 3T by 2 to 2T. The same thing has happened in T by 2 to T. Are you getting this point? So we can see it here. For 3T by 2 to T to 2T, input is gone. Your V0 is at 5 volt. That means your diode will be off. Diode will be off. That means your ID will be 0 ampere. And what will be the scene? This is the capacitor. This is the capacitor which is at 5 volt, and this is the resistor, and it will again discharge. It will discharge in the same manner as in the same manner as 0 to, no, not 0 to T by 2, T by 2 to T. It will discharge in the same manner. Well and good. So now we can draw the final waveform because the same cycle will keep on repeating now. Now we can draw the final waveform. So one V0 waveform I can draw and one IDT waveform I can draw. because the same thing is will keep on happen now. Now what will happen for 2t to 5t by 2? For 2t to 5t by 2, what will happen? The capacitor has already discharged. The capacitor has discharged to this much of voltage. The capacitor has discharged to this much of voltage. Capacitor has discharged to this much of voltage. Then 5 volt will be applied. Then again suddenly there will be a jump. Again suddenly there will be a jump. So what will be the current? Impulsive current of the same magnitude. Impulsive current of the same magnitude will be there. And there will be a one more current, that will be 5 by R, resistor current. So 5 by R plus this current. So this cycle will keep on repeating. That's it. Are you getting this point? So now I can draw the IDT waveform. Also I can draw the V0 waveform. So this is my IDT waveform. It will keep on repeating from 3t by 2 to 2t. ID will be 0. Then again the impulsive current will be there, the 5t by 2R. Then this will be 5t by 2. Then till 3t. At 3t again there will be an impulse, 5t by 2R. And again there is this. And again it will keep on going like this. This is 5 by R. This is also 5 by R. Now this much will not come in action because this is not the steady state. This is the steady state, right? This is the steady state. This is the steady state. This is steady state. Are you getting this point? So this is steady state. So what will be ID average? ID average, I should write like this, IDT average at steady state. What is the formula? Tell me, what is the formula? Formula is area in one time period divided by time period. So area in this much of time period. What is the area? This area, this much of area. What is this much of area? That is 5 by R into 3t by 2 minus t. This much of area plus this area, 5t by 2R. 5t by 2R divided by the complete time period. So that will be, now this will be 5t by 2R only, because 3t by 2 minus t, it will be t by 2 only. So 5t by 2R plus 5t by 2R divided by t, that would be 5 by R. So ID average would be 5 by R. That is your final answer. So this is how you solve this problem, which was very conceptual, but a lot more times I have seen, everywhere I have seen the solution to be wrong, but actually this is the correct one. Impulses and the area, impulses, area, impulses, area. So this cycle is being repeated, so you have to tell the average now. So this is how you get to the final answer. Now after this we will see the gate question which has come in gate, but before that I should draw the V0 waveform, but this will be the V0 waveform only, no? I hope you can draw it by your own. So V0 waveform will keep on repeating like this. V0 waveform will keep on going like this. Right? So this will be your final V0 waveform, and this will be your final IDT waveform. So from here I go to the average value. So let me explain it once again. What is happening? 5 volt is coming, diode is on, 5 volt will be there. Okay. Now there will be a discharging, but discharging will be very low since time t is very, very large. But still there will be some discharging. So we are linear approximating it to the linear. So linear कर लिया इसको. Then what we are doing? After doing the linear one, we got to know that यहाँ पे voltage इतना आएगा 5 into 1 minus t by 2 RC. That will be the voltage. Then suddenly the voltage will rise. If the voltage is suddenly rising, that means there will be an impulsive capacitor current. The impulsive capacitor current we got to know the magnitude is 5t by 2R delta t minus t. How did we find the magnitude? We found the change in the voltage into C. Found the change in the voltage into C. That will be the area of that impulse. So change in voltage into C. So the current came out to be 5t by 2R delta t. So that would be the current, but that is happening at time t equals to t. So I wrote delta t minus t. So by that we got to know that this same waveform is being repeated. So we can draw the final waveform now. So this will be the final waveform. Then we can find the average. So average will be the area of one time period. That would be the area by the this resistor current, that is 5 by R 3t by 2 minus t plus area by the impulse, that is 5t by 2r divided by time period. So the average value we got to know is 5 by r. Now we will see the question that came into gate examination, that is also very conceptual. And at if you see the solution at 10 different institutes, at 10 different institutes the solution is wrong. Everywhere the solution is wrong. Some people are applying some formula, somehow they go to the final answer. But let's see the correct solution now. But before that, try solving it on your own, because it is related to the previous concept only. So here the same kind of circuitry is there, RC circuit, diode. It looks like a positive peak detector circuit, but still there is something different, that is the value of RC. So here what do you see? What is the value of RC? Here the value of RC is 400 millisecond, that is 0.4 sec. Here what is the time period? This is the frequency. So what is the time period? Time period is 1 by 50, that is 0.02 sec. Let's make the input. What is the input given? This is the input given, and this much time is 0.02 sec. This is in the second. So this much time is 0.02 sec. This is 0.01 sec. This magnitude is plus 10 volt. This magnitude is minus 10 volt. What do you need to find? The same thing you need to find. Average steady state current in amperes through the diode. So ID average you need to find at steady state. ID average at steady state you need to find. This is what you need to find. Tell me what will happen. Let's try to make the V0 waveform with a different color of pen. So this V0 waveform also we will draw here, and let's talk about V in. This is your V in. Start initially. So initially 10 this positive cycle is coming, that means diode will be on. If the diode is on, that means capacitor will follow the input. So capacitor will directly follow the input. Are you getting this point? Here 10 sin omega t is applied, that means input is slowly rising, the diode is on. So if diode is on, what will be the circuit? This is the input R and C. Simply capacitor will follow the input. There is no meaning of time period, nothing. Simply the input will be exposed to the capacitor. So capacitor will follow the input. Now what is happening? Now this capacitor is charged to 10 volt. This capacitor is charged to 10 volt. Let's call this as T by 4 and this as T. Now this capacitor is charged to 10 volt. Now what is happening? Here we are having 10 volt and here we are having somewhat less than 10 volt. Let's assume 9.9 volt at this point. That is 9.9, this is 10. So diode will be off. So now your diode will be off. So if diode is off, what will happen? So at T by 2 plus, at T equals to T by 2 plus, diode is off. And if diode is off, what will happen? There is this resistor R. There is no meaning of this because diode is off now. This is the capacitor and it is charged to 10 volt. So the capacitor will start discharging. So your V0 waveform, V0, this is your V0. What is your V0? I did not specify it. This we are taking it to your V0. So V0 will start decaying. So it will decay in this manner. V0 T will be 10 e to the power minus T by 4 RC, right? Why T by 4? Because it is starting from T by 4. At T by 4 plus only your diode is turning off. So it will start from T minus T by 4 RC, right? But you can, since e to the power minus x can be written as 1 minus x if the value is very small. This value is very small since RC is very large. Why RC is very large? You can see in the previous lecture, previous here, RC is 0.4 second while T is 0.02 second. So RC is very large. So you can again approximate it to tan into 1 minus T minus T by 4 RC. Your V naught T will decay in this manner. So here you can draw the V naught T waveform. Here we are drawing. It is decaying, but in this manner, in the linear manner. What will be this potential? This potential will be tan into. Now, what you can do here? So what will be this point? Actually, this is T by 2, not T. This is time T. What will be this point? This point will be 3T by 2. So look, your output is decreasing but very less. Your output is decreasing but very slowly. Although this gap I have made very large, this gap I have made very large, but that is very low. This gap is very low. That means from tan to your output is decreasing. In reality, it would have decreased something like this. So it would decrease till 3T by 2, but somewhat less than 3T by 2. Let's assume 3T by 2 is, what is 3T by 2? 3T by 2 is 0.03. 3T by 2 is 0.03, right? But it would have decreased till 0.299. Till this time, it is decreasing. At 0.299, what you would see that after this, your input is getting higher. So again, your diode will be turned off. What I mean to say, your output is decreasing. Let's assume your output decreases to 9.9 volt, 9.991 volt, and this voltage, input voltage at 0.02999 plus is 10 volt. So after that point, here you are having 10 volt, again the diode will turn on, and again diode turns on. That means again it will follow the input. But to show you in the waveform I have given some space. Are you getting this point? So here I will make one assumption. What is that assumption? That my output is discharging till 3T by 2. This assumption I will make. That my output is discharging till 3T by 2. Did you understand this point? So here I will calculate the value of V naught at 3T by 2. Although it will not discharge till 3T by 2, that's for sure. It will not discharge till 3T by 2, but still I will make an assumption that it is discharging till 3T by 2, because it is discharging very less. It is discharging very less. So nearly it will be 3T by 2 only. So this is the assumption that I am making. Tan into, and this will not be 3T by 2, yaar. This will be T plus T by 4. T plus T by 4 will be 5T by 4. This will be 5T by 4. So I am making an assumption that it will discharge till 5T by 4. Really sorry for this mistake. This will be 5T by 4. One minus here 5T by 4 minus T by 4. It will be T only. Did you understand this point or not? This value I can write. This value here I should not write. In the next page I will write. I will just copy this circuit. Not circuit, this signal I will copy it and paste it here. So this potential I got to know is tan into 1 minus T by RC. Are you understanding this point? And in this much of time, what is happening? Your diode is off. Till this much of time, your diode is off. Well and good. So now how will your waveform repeat? So your waveform will keep on repeating like this now. Again it will discharge. Then again it will charge. Then again it will discharge. Then again it will charge. Again it will discharge. Tell me one thing, where your diode is turning on? Here, what is your diode? What is the condition of diode here? In this, from here to here, let's call this point as point A, and this point as point B, and this point as point C. So in AB region, what is the condition of diode? In AB region, the diode is off. This is the region we are talking about. In this region, diode is off, because first what is happening? Input is followed, then 10 volt is there, diode is off, the capacitor discharges very less, till this point it reaches. At the next moment we realize that input voltage will be higher, that means diode will again be on. So only in this region diode will be again on. So again it reaches to 10 volt. At the next moment input is 9.9 volt. So here 9.9, here 10, that means again diode is off. Then again diode is off, again off, then again on. So diode is turning on in this region only, and in this much of region diode is off. Are you getting this point or not? So here your diode is off. Here your diode is off, and here your diode is on. So in AB region, diode is off. Look, I am giving you the correct solution, and in the correct solution, you have to use your brain. Okay, so keep your brain active, otherwise you will not be able to understand anything. And in BC region, diode is on. So now people will say that that particular region where the diode is on is very less, so there will be zero current. So ID average should be 0. But one thing is happening. V naught, that means capacitor value at 5t/4 minus, I should say. Here I should write minus. Why minus? Because just before 5t/4, just before this point, just before 5t/4 is 10 into 1 minus t by RC. What is the value of V naught at 5t/4? That is 10. So the capacitor is changing its voltage almost instantaneously. Although it is not instantaneously, it is following linearly, but still you can say it is almost instantaneously. The capacitor is changing its voltage almost instantaneously. From 5t/4 minus, it was 10 into 1 minus t by RC. At 5t/4 plus, it is 10 volt. Are you getting this point or not? So almost instantaneously it is changing. Did you understand this point? So V naught value at 5t/4 plus is 10 volt. And what was your V naught value at 5t/4 minus? It was 10 into 1 minus t by RC. We can make capacitor at this capacitor. This was the voltage, and then suddenly it rises to, this is the capacitor, it rises to 10 volt. This is how it is rising. So in this much of area, that is a very less area, and here the resistor current cannot come. Although what you can say, although this 10 volt is nearly constant, right? Here it was 10 volt, the output decreases, but it decreases very less, till 9.9 volt only. It decreases very less. So this 10 volt is nearly constant, right? This 10 volt is nearly constant. So you can say that the resistor current will always be constant, that will be 10 by R. This resistor current will always be 10 by R, because the same 10 volt will be coming across this. So there will be this resistor current as well. But the area is very less. Although there will be 10 by R current, but for how much time? 0 ampere time. Not 0 ampere time, sorry, 0 second time. What do I mean to say is that here your diode is turning on, here your diode is turning on. So what I will write, that my IDT is IRT plus ICT. What is my IRT? IRT is 10 by R. Certainly it is 10 by R. You can nearly say that the current is nearly constant. Here your capacitor voltage is changing, but very less. From 9.99 volt to 10 volt it is going. Very less it is changing. The capacitor voltage is changing. At 5t/4 minus, it was 9.99 volt. This can be approximated to 9.991. And then it is changing to 10. From 9.999 volt to 10 volt. So the capacitor voltage is, the resistor current is not changing that much. It will be nearly 10 by R only. So you can write that your diode current will be resistor current, that is 10 by R, plus the capacitor current, which is change like this. So what will be the change here? 10 into, so final is 10 minus initial is 10 minus 10t by RC. So that would be 10t by RC, but it will be multiplied with the C value because we are writing the current into C delta t minus 5t by 4, because all is happening at 5t by 4. So the current is 10t by R delta t minus 5t by 4. This is the current. So plus 10t by R delta t minus 5t by 4. And this will keep on happening at this time, at this time. So after every time period t, this much of window, what is this much of window? From here to here. So after every time period t, this will keep on repeating. After every time period t, this will keep on repeating. What is my output waveform? Output waveform is this. So I can draw my output waveform. Steady state output waveform only I will draw. Okay, steady state only. So how is my output waveform looking like? So first it is decreasing like this. From t by 4 we are starting. From t by 4 we are starting. First it is decreasing. Then it increases a bit. Then again it decreases. Then it increases a bit. Then again it decreases. It keeps on going like this. This is your V naught waveform at steady state. What is this time? This time is t by 4. This time is t by 4. This time is t by 4. And what is this time? 5t by 4. This time is 5t by 4. This time is 5t by 4. What will be this time? This time will be 5t by 4 minus 5t by 4 minus. What will be this time? 5t by 4 plus t. 5t by 4 plus t. That will be 90 by 4. And what will be this time? 90 by 4 minus. So in every time period t, the waveform is being repeated. In every time period t. Now what about IDT? What about IDT? IDT. Tell me one thing. In this region, what was happening with the diode? Diode was off because the capacitor was linearly discharging. So in this region, diode was off. Here in this region, diode was off. This was the region where diode was off, right? And in this much of region, diode was on. So here diode was off, and here your diode was on. Off and on. If the diode is off, that means ID current is 0. ID current is 0. Now the interesting thing will come. Now diode is on. If the diode is on, there will be resistor current as well, and there will be this impulsive current as well, right? So for this much of time, there will be resistor current as well, and there will be impulse as well. Time is very less, 5t by 4 to 5t by minus 4. And again the diode will be off. Here there will be impulse as well. Impulse as well. This impulse will also be there. Then again there will be this much of window. And also an impulse is there. Well and good. The magnitude should be the same. What is the magnitude of this impulse? The magnitude of this impulse is 10t by r. 10t by r. 10t by r. And what is the gap between this? This gap is time period t. Then again after time period t, it will repeat it. It will be repeating. Now interesting thing is that what is this magnitude? That is 10 by r, right? The current is IR current is 10 by r. 10 by r. This current is 10 by r. Now what is the interesting point? The interesting point is this point is 5t by 4 minus and this point is 5t by 4 plus. What is the time window? Time window is nearly 0. Time window is nearly 0, right? This time window is nearly 0. Now you have to find the average. What will be the average? Average will be the total area. Area in case of impulse, this will be the area 10t by r, plus in case of resistor, what will be the area? The magnitude into the time window. What is the time window? 5t by 4 minus to 5t by 4 plus. What is the time window? 0. Although there is a resistor current that is 10 by r, I admit that there is a resistor current, but the time window is 0. Time window is very, very less. That is nearly equals to 0 only. So 10 by r into 0 divided by the total time period. So what is the average ID current? ID average. So what is ID average? ID average is 10 by r. And what is the value of r given? Value of r given is 100. That will be 10 by 100. So answer is 0.1 ampere. That is the correct approach. That is the correct solution. Only correct solution is this. Rest all the solution are wrong. I can write it on paper and sign it. But all other solution are wrong. This is the only correct solution. What other solution I have seen, what they do, some apply some formula, but some other teachers, what they do, like they say that this current will be almost constant, 10 volt. This voltage will be almost constant, right? Because this is not much discharging, so it will be at 10 volt only. If this is 10 volt, the current in the resistor will be 0.1 ampere. And if this 10 volt is constant, that means the capacitor is having constant voltage. If there is constant voltage across the capacitor, that means there is no current in the capacitor. So the current will be 0 ampere in the capacitor, and this 0.1 ampere will be the diode current. That's it, that's the answer. But that is completely wrong. If they had asked in the question that what is the average capacitor current, then people would have marked 0 ampere and the answer would be wrong. Average capacitor current is not 0. Average capacitor current is 10 by r, and that is same as the diode current. So in the next meantime, I am expecting that they are going to ask the average capacitor current. Here in this question also you saw that the average capacitor current is not 0. Average capacitor current will be 5t by 2r divided by t. So that would be 5 by 2r. So average capacitor current is not 0. Impulses are there, no. Impulses are there. So you can't say that voltage is constant. Your voltage is changing instantaneously. Impulses are there. That's why your voltage is changing instantaneously. So here you can't say that your diode current is coming because of the resistor current. No, your diode current is coming because of the resistor current plus the capacitor current, and only when your diode is on. At the time when diode is on, only at that time we will see the resistor current and the capacitor current, and based on that we will write our diode current equation, and better writing the equation we will make the waveform, and the waveform came out to be like this. So the waveform came out to be like this, and then we could get to our final answer, that is 0.1 ampere. So how did we solve it? Let's revise it once again. So first what did we do? For 0 to t by 4, we saw that it is following the input. This is not the steady state. Then what will happen? The diode will be off. So the waveform will go down, but it will go down very, very slowly. It will go down till 5t by 4 only, nearly 5t by 4 only. Then when we saw the input is getting higher than the capacitor voltage, the diode will again turn on. Then again it goes down, again turn on, again it goes down. So the waveform will keep on repeating like this. So when the diode is off, this would be the capacitor equation, capacitor voltage equation or output voltage equation. So this would be the output voltage equation. Then we can linearize it. Then we linearize it and found the voltage at 5t by 4 minus. The voltage at 5t by 4 minus was 10 into 1 minus t by rc. And suddenly it is rising up to 10 volt. It is not sudden, although the rise is like sinusoid only, but you can call it sudden only because that is happening in very less time. So the rise is from 10 into 1 minus t by rc to 10 volt. So it is rising like this. So from there we can find the, what we can find? We can find the capacitor current. The resistor current is almost constant because output is almost constant at 10 volt. This voltage is nearly equals to this voltage is nearly equals to 9.99 volt only. So your output is almost constant at 10 volts. So the resistor current would be 10 by R. So this is the resistor current 10 by R. Then we made the V0 waveform and the ID waveform. So ID was in this much of region, ID was 0 ampere only because the diode was off. When it is turned on, there is resistor current. Certainly there is a resistor current, but the time window is very less for resistor current. 10 by R, the time window is 50 by 4 minus to 50 by 4 plus. That is 0 time window. So the value given by the current would be 0 ampere, but from the impulse, the value you will get is 10 T by R divided by the time period. So the ID average you would get is 10 by R. So the current would be 0.1 ampere. That's it. Understood? Well and good. All clear? Right? So I hope you liked the lecture. I hope you understood the complete concept. This one question is remaining that we will see in the assignment. That was asked in GATE 2016, which is not related to all these concepts. It is very simple question. So we can see that in assignment problem. Okay. So in the next lecture, we will see voltage doubler and tripler. And in the assignment, we will deal this problem. Till then, you can solve it on your own. Answer will be, as far as I remember, nearly 2.1 volt or 2 volt. So the range given was 1.1 to 2.1 volt. So you can solve this problem till that time. Then we will see it in the assignment. Okay. Thank you. So if you liked the lecture, please do share it with everyone so that everyone can benefit from it. Thank you.